Let's talk about implicit loops, also known as vectorized operations. Unlike explicit loops that iterate over individual elements in a vector like the for loop or the while loop, implicit loops are operations over an entire vector or matrix in a single step, resulting in cleaner and more efficient code. In R, operations like addition, subtraction, multiplication, and division, and many functions are built to work with vectors and matrices. For example, additions are automatically applied to each element in a vector, or each corresponding element in two vectors. If two vectors don't have the same number of elements, the elements of the shorter vector are recycled. For example, if I add this vector a1 with 4 elements and this vector b1 with 2 elements, these 2 elements will be reused so that in effect, this second vector is 10, 100, 10, 100, which are then added to the corresponding element in a1. In this case, where b2 has 3 elements, the elements will be recycled so that it becomes 10, 100, 1000, and finally 10 again. Vectorized operations are not limited to vectors. They extend to matrices and arrays as well. This means you can perform operations on entire rows or columns or a higher dimension in a single step. Especially note that the regular multiplication operation will be element-wise. So each element in the vector or matrix or array will be multiplied with an element in the same position in the other object. For matrix multiplication, as in linear algebra, use the operator %*%. Other than basic arithmetic operations, many functions are vectorized. Functions such as mean, sum, and square root can be used on vectors to perform operations on each element in a single step. For example, the function square root automatically calculates the square root of every element in the vector. And the functions sum and mean automatically sum up all elements in the vector or calculate their mean. For more nuanced operations looping over elements in different data structures, you can use the apply family of functions, including the apply function, list apply, multivariate apply, tagged array apply, and more, each designed for different data structures and use cases. The apply function, applies a function to the margin of a matrix or array that you specify. 1 is for rows, 2 for columns, 3 or higher for other dimensions in an array. Here, the function mean is applied to every row in the matrix D. You could also define your own function here. The list apply function is useful for lists. It applies a function to every component in a list, and then returns the results also in a list. If the results can be simplified to vectors, for example, if the results are a list of individual numbers, they can be unlisted into a vector. Or you can use a related function, simplified apply, which performs similarly to list apply but outputs a vector. Or the vector apply function, which allows you to specify the output structure. There are other useful functions from the apply family that you should explore. For example, recursive apply is for nested lists. Multivariate apply for 2 or more vectors and lists. And tagged array apply for subsets of vectors. The data vector is grouped into subsets by a factor. Here, these 2 elements are in group A, these 2 in group B, and these 2 in group C. The tapply function applies the function sum to every group here, resulting in 3 numbers. Remember that using vectorized operations or implicit loops in R not only makes your code shorter, but also significantly faster. especially with large datasets.